Hey, I got to do a lab this weekend, I guess. I recorded it yesterday, so Monday. Essentially what I did is I hung a pendulum, they called a pendulum bob, from my garage overhang. And I've got a string, real thin string, out to a mass that has pink and yellow paper on it. And what I did is I released it and I tracked its motion. So let's see if we can do this. I'm going to pull that down here. So remember, I set up the axes. This is 0, 0. This is the positive x direction. What's that mean? I think down, right? If this is a grid, down would be the positive y direction. So if this is at 0, if it swings down, I'll have a positive direction. And then when it goes to the left, I'll have a positive direction in the x also. So let's just see if I can play the video, and you'll see what points I've selected. Sorry, I got some verbal going on. I have a full video. And I can just pause that. And you can see, as it's gone through its motion, it creates this big arc. So my y value should start at 0, go to a peak, and come back to 0. A little bit higher, I didn't track it right by my nose. And then the x position should go out, far away, and back. So we'll see if it's steady or not. So this is the y position, and that seems to make sense. As far as it starts at 0, goes far away, and then it comes back. Now I'm going to put some stats on here, because that should give me max, min, average, etc. So what I'm going to do, let's see if I've got options, appearance. I'm going to try to make that just a little bit larger. Let's see if that did it. Good. So let's see, max. It's 0.81, call it 0.8 of a meter, and then it's at 4.403 seconds. So as far as the maximum value, it's at about 4.43 seconds. I'm going to go to the x position. I've got x velocity right now, but let's go x position. So what is that saying? Boy, what is that saying? I think it's going out, right? And maybe it's just coming back. It seems weird, but over time, where is that position? So it's making a bunch of sense for me, but I thought it might come back. But let's look at velocity, because what I want to talk about is this relationship between potential energy and kinetic energy. So let me get some stats on that one, and I will, oops, get those also bigger. What was that, 16? Okay. Stats for this, and it seems to have this peak as far as velocity. So it starts slow, right? And then it speeds up, right? And then it hits that max, and then it slows down again. Where is that peak? So max is at 3.39 meters per second is what I would call it. And then it's at 4.4 seconds. Notice that, 4.4 seconds, 4.4 seconds. So the velocity peak and essentially the lowest point of the pendulum in the y direction and the maximum velocity line up, okay, which I think is kind of cool. So I can put y values on this. It's not really going to make a lot of sense, but you can kind of see how the peaks line up there. Okay, so let's go back to the video. Okay, let's see if we can slide it. Right here it's at 0 y value. Okay, and it's at its maximum, I guess, height is what you'd call it. Okay, there is 0 velocity at that max height. Okay, 0 velocity at that max height. And then as it progresses, right, as it progresses through, oops, right, let's get back. I'll go screen by screen. Let's see if that'll do it. Right, as it progresses through this, you can kind of see the gaps widening, right? It's hitting its low point, right? And in between there, the velocity is starting to increase, right? And at its lowest point, right, at its lowest point, where, who knows where that is necessarily, it's not straight up and down, so somewhere around here, right, is where it has zero potential energy, right? At its highest point, it had all potential energy, and down here, it's got its lowest potential energy. As far as kinetic energy, it wasn't moving, zero kinetic energy, but now it's at its maximum kinetic energy. So when we have a pendulum, we can have our maximum all potential energy when it's stationary, all based on position, and once you release it, it's a combination of potential energy and kinetic energy, all adding up, right, to the stored energy at the beginning. This is the concept of conservation of energy. Energy cannot be created nor destroyed. So if I have, say, 30 joules of energy up here, there's still 30 joules of energy here. It just happens to be all potential energy up here. It's a combination of potential and gravitational potential energy. But when you get down to that low point, it's as low as that bob is allowed to be, so it has zero potential energy. That means it's all kinetic energy. So I'd still have, if I started with 30 joules here, it's all the kinetic and potential add up to 30. Even down here, right, it'll still be 30 joules, but it's all kinetic energy. And we can use the concepts with our equations. Gravitational potential energy is mgh. Down here, kinetic energy, it's all kinetic energy, is 1/2 mv squared. Well, since they both have the same energy, the energy has not been created nor destroyed, 30 joules equals 1/2 mv squared, and 30 joules equals mgh. I can calculate that speed based on the gravitational potential energy, okay? So that's kind of the point of this video and the lab, is for you to see at its max, I guess, depth, right? It was at 0, but that's at my eye level, and it goes down in a positive direction to its low point. That's where it has zero potential energy. It coincides right at the same time with the maximum velocity, which means the maximum kinetic energy. So I hope that kind of gives us a little starter. It means I can calculate, right? I'm going to show you some calculations. I can calculate that speed, and I'll try to remember it here. What was that max speed? 3.95. I'll have to measure the length of that pendulum, and I'll show you how I can calculate that speed based on the pendulum length and the height at which it got. All right, that's all for now.